All right, so this is the explanations for the warm-up that's reviewing for your quiz. So make sure that you've tried every single one of these problems on your own before playing this video. If you don't remember how to do something, remember to look back at your notes. So if you haven't finished yet, make sure you pause the video and then start listening to the explanations. This is to prepare you for the quiz, so make sure if there's anything you don't understand that you pause, rewind, and watch again, and ask questions of don't just watch the video, you can also ask questions of people around you so that they can explain it if you're still struggling to understand after watching it twice. All right, so hopefully the first thing you did on this was made your list of perfect squares, right? So 1, 4, 9, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and that's probably about as far as you would really need to go, right? So, number 1 should be the easiest ones of them all, because this is the one where all you really have to do is simplify. So all we care about is finding the largest perfect square that goes into 48 evenly. In this case, the largest perfect square that goes into 48 would be 16, and 16 goes into 48 3 times, and make sure you bring your -8 down out front. So now you can go ahead and take the square root of 16, which is 4, bring down your square root of 3 and the -8 out front. Remember, since there's nothing between them, that means we're multiplying. So we're doing -8 times 4, which is -32, square root of 3. Okay, now let's look at number 2. Now number 2 is addition. So we need to remember and we need to remind ourselves that when we're looking at problems that involve addition, that they must have like radicals. Remember, that means they have to have the same number in the radical to combine. They must have like radicals to combine. And if you can combine them, you add or subtract the coefficients, which remember is those numbers out front, but the number in the radical stays the same. So this is key, right? If they're like radicals, these are the steps, but you have to have like radicals first. So in this case, when I look at these, none of my radicals are like radicals, which means I'm going to need to reduce them first. So remember, we look at them one at a time. So I would completely ignore all the rest of these and just focus in on this 6 radical 20 and simplify it like we did number 1. So the largest perfect square that goes into 20 is 4, which goes in there 5 times. And remember, you must bring the number out front down. Then you can go ahead and take the square root of 4, which is 2. Bring down the 6 and the square root of 5, and you must multiply those outside numbers together. So 6 times 2 is 12, square root of 5. Then I'd go ahead and bring my addition sign down in the middle. Now I don't need to worry about the 6 radical 20. I can just focus in on the next part, which is the square root of 3. Well, the square root of 3 doesn't have a perfect square that goes into it evenly. So even this one, all I really need to do is bring it down. Now when I bring this one down, I would even put a 1 out front to remind myself that the coefficient to that problem is 1. Then we look at the next one, and again, 5, there is no perfect square that goes into 5, so we go ahead and bring that down, the -4 root 5. Then we look at the last one. Well, 27 has a perfect square that goes into it evenly, and that perfect square is 9. 9 goes into 27 3 times. And then we have to bring down the 2 out front, and don't forget to bring down the plus sign, right? In this case, the square root of 9 is 3. So I have a 2, a 3, and a square root of 9, and we need to multiply that 2 and 3 together to get 6 radical 3. So now I need to look for like radicals. In this case, we have a square root of a 12 square root of 5 and a 4 square root of 5, and it's a minus. So we're going to go ahead and combine the coefficients. We only add the coefficients. The number in the radical will stay the Sorry, not Sam. It'll stay the same. So 12 minus 4 would be 8, and the radical 5 comes along. Then my other like terms are this positive 1 root 3 and my positive 6 root 3. Well, positive 1 plus 6 would be a positive 7, and the root 3 comes along. And since those are not like radicals, that's as far as I can go. Now remember, the big thing is there's a big difference between what you do when you multiply and what you do when you add and subtract. So when you add and subtract, you have to have like terms. So remember that. So if we add or subtract, must have like terms. And since we must have like terms, that means our first step is to reduce, and then our second step is to combine. I'm sorry, it's really not reduce, it's really simplify. So my first step is to simplify when we're adding and subtracting, and my second step is to combine them together. But multiplication works completely differently. When we're dealing with multiplication, we don't care whether or not the radicals are the same. You just go right ahead and start multiplying everything together. We don't care if they're the same number or not. And then once you multiply everything together, then you reduce. So they really work in opposite order, right? Adding and subtracting means you reduce and then combine. Multiplying means you multiply and then reduce. So we do them in opposite order. So I don't even care that these are different. I just go ahead and I multiply my outside numbers together. So negative 2 times 3 is negative 6. And then I multiply my inside numbers. So 18 times 3 is 54. Now that I've multiplied everything, I can go ahead and, again, not reduce, I mean simplify. So we are going to find the biggest perfect square that goes into 54, which is 9, which goes in there 6 times, and we bring down our negative 6 out front. The square root of 9 is 3. Bring down our square root of 6 and our negative 6 out front. There's multiplication between these. So then we end up with negative 18 square root of 6. All right. Number 4 is very similar to this because, again, it requires multiplication. But remember, whenever you see this exponent of 2, that means I'm going to take whatever's in the parentheses, which in this case is negative 6 square root of 2, and multiply it by itself. So again, since it's multiplication, we multiply everything together first. So I'm going to do negative 6 times negative 6, which is positive 36. Then I'm going to do square root of 2 times square root of 2, which is the square root of 4. Now that everything's together, now I simplify. The square root of 4 is 2. Bring down the 36. We multiply them together to get 72. Okay, so now 5 and 6 really start to combine these ideas together. But again, since there is the parentheses, we know it's multiplication, so we're going to start out by distributing first. So we're going to multiply 2 square root of 3 times 5 square root of 2. I'm not even going to worry about doing the other distributing. Remember, do this one piece at a time so you don't get overwhelmed. So we can do 2 times 5, which would give me 10. And we multiply our inside number by our inside number. So 3 times the square root of 2 would be the square root of 6. And then I need to ask myself if there is a way to simplify the square root of 6. And there's not a perfect square that goes into 6, so we're done with that piece. Then we're going to go ahead and we're going to take our 2 square root of 3 and multiply it by negative 6 square root of 3 because of the minus sign. So 2 square root of 3 times negative 6 square root of 3. And again, since we're multiplying, we multiply everything first. 2 times negative 6 would be negative 12. 3 times 3 would be the square root of 9. Now that it's all combined, we simplify. So the square root of 9 is 3. Bring down the negative 12 out front and multiply those together to get negative 36. Then I can go ahead and bring down my piece out front, which was 10 square root of 6. If these were like radicals, we would combine. But since one of them has a square root and the other one does not, then this is my final answer. All right, last one, which is basically the same thing. All right, so we're going to start out by distributing. So we're going to do square root of 6 times 2 square root of 3. So in this case, there's only one number on the outside. So either I can put a 1 on the outside over here to remind myself it's there, or I would just bring down the 2, because again, 1 times 2 just stays 2. Then we're going to go ahead and multiply our inside numbers. So 6 times 3 would give me square root of 18. Now that I've multiplied it, we need to simplify. So 18 can break up into the square root of 9, square root of 2 with the 2 out front. The square root of 9 is 3. Bring down the square root of 2 and the 2 out front. Now remember that there's multiplication between these two, so it really is just 6 square root of 2. Then we're going to go ahead and distribute with the last one. So we're going to do square root of 6 times positive 5. So square root of 6 times positive 5. Now be careful with this one again, because in this case there's only one number on the inside, there's only one number on the outside. But I could add this 1 here to remind myself that I'm doing 1 times 5, because they're both on the outside, which is 5. There's no other number on the inside, so we just bring down the square root of 6. Now I need to decide if there's a perfect square that divides into 6 evenly, and there's not, so I'm just going to go ahead and bring that down, and since it's positive, I'll put a plus sign, so it's plus 5 square root of 6. Now, if these were like terms, we would need to add the coefficients and keep the radicals the same, but the radicals are not the same, so we're done. All right, so if you're feeling confident, you can go ahead. Well, first of all, take this when you're finished, pass it to the back of your row. Last person in each row, please turn it in, because I'm going to check to make sure that you corrected things as we went along. If you're feeling confident, then you can go ahead and move on to the quiz. If not, then I've got a few extra sample problems that you can try if you go to the next video.